Okay, so 1.2 is functions and graphs. We'll have a decent amount of notes, and then we'll do some examples. So just a reminder, I'm sure you've heard this all the way since Algebra 1, but the domain are the inputs, okay, or the x values. The range are the outputs, or y values. A function from a set D to a set R is a rule that assigns a unique element in R to each element in D a natural domain is the domain assumed to be the largest set of x values for which a formula gives real y values.
Oh. I looked at the one song in our grade. I was confused. I was like, angle side to side?
I'll fix it for you.
I'm
There you go.
I've been up since 4 a.m. So.
Why?
Because I had the gym because they changed the time.
Oh.
To the gym to 5 o'clock.
That's unfortunate.
6.
I'm not a morning person, so. All right, a boundary is made up of endpoints. Or they're also called boundary points. Anything that's not a boundary point is an interior point or an interior. It's all remaining points. If we have a closed interval, it is one that contains the boundary points. Open intervals do not contain boundary points. last year, you might remember we did the tables of stuff and we had open and closed intervals and we showed like if they had the endpoints or not, if they were dealing with just numbers like from A to B, or if it was like from A to infinity or B to negative infinity, or negative infinity to B, I guess technically. Things like that. So that's where this comes back into play.
Those are the bracket parentheses then.
Yeah.
Yeah. We talked about this.
All right, and then even and odd functions. And dealing with symmetry. So a function y is equal to f of x is an even function of x if f of negative x is equal to f of x, and it's an odd function of x if f of negative x is equal to negative f of x. So remember, you plug in negative x, and if the whole thing comes out negative, then it's odd. If the whole thing comes out to be positive, then it's even. And that's for every x in the function's domain. The graph of an even function is symmetric about the y-axis the graph of an odd function is symmetric about the x-axis. Or sorry, the origin, not the x-axis. Do y'all remember piecewise functions? They kind of look like the steps a little bit. They have like open circles and like jumps and stuff.
Oh yeah.
So we have a little bit of a variation of that. It's still the same idea, but it just looks a little different. But they're just functions defined as pieces. Or in pieces, I guess is a better way to say it. Come on, what's going on? So if we have something like y is equal to f of x is equal to, and this is when we do the little curly bracket thing, and we have negative x for x less than 0, we've got x squared for 0 less than or equal to x less than or equal to 1, and then 1 for x greater than 1. We would end up with a little graph that will look something like, we've got negative x until we get to 0, and then it's kind of a parabola until we get to about 1, and then it's just equal to 1 from there on out. So that would be kind of a rough graph of what that looks like piecewise. Okay, we can also do with similar thing with absolute value functions. So y is equal to the absolute value of x is defined piecewise. By y is equal to, or well, actually here, I don't want to write it that way. The absolute value of x is equal to negative x for x less than 0 and positive x for x greater than or equal to 0. It doesn't really matter which one of them has the or equal to part on it, because as long as one of them includes it, then we're good. And so for this, we would have a little graph. That's crooked.
Is that the one where it looks like a
Yeah.
bee? Yeah.
So we've got
And then he had us do transformations on these.
something like this. Yeah, now you get your calculator for that. So those are the two graphs piecewise. They're drawn. It's not a perfect V because, yeah, anyways. So the domain for this would be all real numbers, or we could write it as negative infinity to infinity. For this one in particular, the range would be from 0 to infinity. Okay. Obviously, if it was shifted down, then it would be wherever that value is from, whatever your smallest y value is out to infinity. Or if it was reflected, obviously then we're dealing with negative infinity to 0 or wherever it is. And then the last kind of function that I just kind of want to remind you of are composite functions. And these are functions that are composed of another. So there's two ways to kind of write it. It's f of g of x, or f and then inside g of x. Okay, either of those notations is completely fine. Both mean the same thing. And we'll jump down and do some examples here. All right, so these problems in your book, they're not really word problems, but they're like a sentence or two. So I'm not gonna like write the whole problem out, just be aware. But it says to write a formula for the function and then use it to find the indicated value of the function. So we're gonna look at number 2. So this one, we have a height h, I'm just gonna write important things, of an equilateral triangle and it's a function of its side length s. The height of the equilateral triangle of, and it wants to know the height of the equilateral triangle of side length of 3 meters. So we want to find that the side length is 3 meters. All right, so we know it's equilateral, so what does that mean about all the angles? Okay, they're all the same. And if a triangle is 180 degrees, what does that mean? The angles are 60 degrees. So I'm going to draw Not a very good equilateral triangle, but it's close enough. Yeah, it's fine. Okay, so we've got our side lengths all around here. Okay, but this little area from here to here is half of the side. Okay, all the angles are 60 degrees. So if I'm dividing this in half to give me something that I do know, that means that this side is going to be 30 degrees. Okay, and this is the height here of the triangle. So that's all the stuff that I know. What do we know to be true about a 30, 60, 90 triangle? What's true of their side lengths? Close.
5. 2, 5.
You had 2 and root 3 correct. Your other side is wrong.
This side's 5.
Huh? Yeah. Okay, so the square root of 3. 1, 2, 3. So 2 is the hypotenuse side. Square root of 3 is the opposite of 60, and then from 30 it's 1. But obviously we're dealing with some other little pieces here, okay? Because for us, this one is really going to be 1/2 s. So I need to basically take half of all the stuff that I've got to really be able to deal with it. So if my... So I've got this really being 1/2 s there. Then comparatively, this is my s, so that means my s has to be equal to 2. So now I've got my height is equal to square root of 3 over 2 times s, because of this being 1/2 s when this should have been a 1. And then obviously that's changing with the change of the side length. In this case, we're told that the side length is 3. So this is the formula we are looking for. And then h is equal to, we're going to replace s with 3. So 3 square root of 3 over 2 is my height there. And it did say it was in meters, so we'll tack that on. So a lot of this is comparing it to things that you already know to be able to do it. Let's see. Let's do another one of those. Let's do number 4. So with this one, we've got the volume of a sphere as a function of radius. Yeah, as a function of the sphere's radius. The volume of the sphere of radius 3 centimeters is what we're dealing with. Do any of you happen to know the formula for the volume of a sphere?
Isn't it circumference times. You like do the thing of a circle, and then you multiply it by the circumference.
Definitely not circumference, but you're kind of on the right track with the circle thing. It's 4/3 pi r cubed. That's a formula you will need to make sure that you're aware of. Okay, it's one that you'll need to keep in your brains all year. We do a lot with those. So then with this one, that's already the formula. That's just kind of a known formula. We didn't really have to come up with one. So now we just need to plug in. It said that the radius was 3 centimeters. So V is equal to 4/3 pi times 3 cubed. And we would cancel one of the 3's out, so then that would give us 9 times 4 is 36, so 36 pi centimeters. And obviously the units get cubed as well, and you can just leave it like that. You don't have to multiply the pi through. For things like 5 through 12, we'll look at a couple of them. It says to identify the domain and range and to sketch a graph of the function. All that I really want you to do with that is graph it on your calculator and read off the domain and range. So, let's see. Number 6, so we have y is equal to x squared minus 9. So you can literally just put that into your calculator. Got all kinds of stuff going on here. Clear a bunch of stuff. So we'd put in the x squared minus 9, and I would just do zoom standard. Okay, so with this one, we've got a parabola that has been shifted down 9 units. So in this case, our domain, okay, what is the domain of a parabola? No. What is the domain? Yeah, all real numbers, so it can either be all real numbers or you can write it negative infinity to positive infinity. Either way is fine. My range, if my parabola has been shifted down 9 units, what is my range? Everything over negative 9. So it's going to be a bracket including negative 9 all the way out to infinity. All right, and then for my square root function, we're going to do negative of the square root of negative x. Okay. So I'm going to go back. Let's see. Negative square root of negative x. Now, this is probably one you're not as familiar with. Normally, for a square root function, it looks something like this, okay? But in this case, because of what's going on with this one, it looks a little bit more like that. Okay, it's essentially been reflected down and then over is essentially what has happened to it. So that's why it looks kind of like that. So if I were to give you a function that looks like that, what would the domain be? Negative infinity to 0, and we will include 0 because obviously we can take the square root of 0. And then the range for that would be what? Yep, it's going to be the same thing, negative infinity to 0. Okay, because technically it may not look like it in the picture, but in all technicality, if you kept going out to infinity, your graph is going to just keep going down, and so that's where that's coming from to cover all of those. Just because it's a little weird, let's look at 12 as well. We've got y is equal to 1 plus 1 over x squared. So, equals, all right, 1 plus 1 over x squared. So with this one, if you're not familiar with what this graph would look like, essentially it does this and does this. Okay, it's got asymptotes here. This isn't really good. Okay, it's got asymptotes at 0. So what does that mean for my domain here? Yep, and we're not including 0, so it's got the parentheses around it. And then how about the range? This one you probably aren't going to be able to tell just from my graph. I'll just tell you it's shifted up 1 because of the 1 plus, so yeah. Hitting the locks on these wheels. 1 to infinity, not including 1 because there's technically an asymptote there. Okay, if the 1 plus wasn't there, then it would just be 0 to infinity, but that 1 has caused it to shift. It would be kind of hard to see that on your calculator, so that might be one that I'd be a little more flexible with if I were to give you that on a quiz or a test or something. As far as, like I said, the instructions say to sketch the graph. When I give it to you on a quiz or a test, I won't require you to sketch the graph, but if you want to, just show what was on the calculator, that's fine, but I wouldn't expect you to do it by hand, I guess is where I'm going with that. Let's see, got like 2 more and then we'll be done, or well, 3 more, I guess, so we can get a couple things in. Determine whether the function is even, odd, or neither. Try to write the answer without writing anything except the answer, but I'll show how we get them for the sake of this, but if y'all can just see it when you do it, that's fine. So 22, y is equal to x plus x squared. Okay, if looking at it, would you think that's even, odd, or neither? Even? Everybody agree even? Anybody think anything different? Alright, so let's check. We're going to put in negative x plus negative x squared. Oh, the squared goes on the outside. So this stays negative x plus x squared. Because it doesn't make the whole thing be negative, okay, it makes only part of it be negative and the other part is positive. That means it's neither. So it's not even or odd. Let's see. 26, we've got y is equal to x plus x cubed. What do you think about this one? Odd. Everybody agree with odd on that one? Okay. So I'll go ahead and tell you you're right because we put in negative x and these still come out to be negative. Okay, so I could technically pull the negative out front to really show exactly, and so that means it's odd. And then one final one, 30, which is y is equal to 1 over x squared minus 1. What do we think about this one? Even, odd, or neither? Even? Okay, so I put in negative x and square it. So that comes out to be 1 over x squared minus 1. Gives us the same thing we started with up there. So that means it is even. All right, so your problems. Okay. Like I said, if you feel like you understand it, I'm not super picky about how many problems you do, but those problems there would be my recommendation based off of what we did. Would be to look at those ones. Even, odd, or neither problems are really something that I'm inclined to give you, and those little word problems at the beginning, you're likely to see one of those. So I would say if you're going to focus somewhere, do that. I think the domain and range y'all are probably pretty good with, but obviously practice is always good. And so that's kind of a wrap on 1.2 with that.